The discovery of a new exoplanet has astronomers excited that it could be indeed signs of life.
This is a huge discovery, and we think that it's a huge discovery.
Have found a terrestrial planet orbiting Proxima Centauri. It's the nearest exoplanet we will ever found because it's the nearest star to the Sun.
The discovery of a new exoplanet has astronomers excited that it could be indeed signs of life.
It was ultimately discovered by the James Webb telescope to be 7 trillion miles distant. It has lately discovered something astounding. Far-off glows coming from Proxima Centauri b, a planet 7 trillion kilometers away that remarkably resembles city lights on Earth. Do these really represent signals from extraterrestrial life? What if the greatest discovery in human history is just around the corner? As we reveal the mysteries of Proxima Centauri b via the lens of our cutting-edge observatory, be ready to be astounded as we uncover the mysteries of extraterrestrial lights. The telescope discovered these peculiar lights on Proxima Centauri b, a distant star outside our solar system, while scouring the expanse of space. The lights have a similarity to what we see when we look at cities at night on Earth, which raises the exciting possibility that there may be an extraterrestrial metropolis on this far-off planet. Scientists are ecstatic about this prospect because it may be the breakthrough they have been waiting for. It raises the question of whether sentient creatures exist and if the earliest indications of their existence may already be in front of us. They may even be existing in ways that we haven't yet considered. A scientist observed that the lights were flickering at strange times as the data came in. Did it seem random or like a message? The group argued, with each spark posing new queries. Meanwhile, everyone is worried as a mission to investigate is in jeopardy because of technological issues. The world watches, curious as to whether we will soon learn that we are not alone in the cosmos. NASA experts are shocked that these lights could be found at such a great distance. They can't help but wonder how long these lights have been shining unseen until our technology improved to the point where it can recognize them. Columbia University astronomer David Kipping has made observations on this planet's complexity because of its special interaction with its star, Proxima Centauri. Proxima Centauri b seems to behave differently from typical rocky planets, which absorb sunlight and emit heat. The intriguing element, though, is that this discovery goes beyond the simple observation of lights in space. It also demonstrates how crucial the James Webb Space Telescope is to our understanding of the cosmos. It not only raises the prospect of life beyond Earth, but also challenges us to consider what life may be like elsewhere in the universe. Is it possible that societies exist that operate entirely differently from one another? The telescope's exceptional ability to capture infrared light was crucial in identifying Proxima Centauri b's distinct heat patterns. This discovery is significant since it advances our knowledge of the planet's atmosphere. Currently, scientists intend to utilize it even more to probe the planet's atmosphere and determine whether life may exist there. The James Webb Space Telescope is particularly well known for its capacity to identify infrared light, which makes it an excellent tool for studying Proxima Centauri b. At night, this telescope can detect even the smallest light in space, whereas others have trouble picking up on dim light. Because of this, it's the ideal instrument for verifying if artificial light may exist on the planet's dark side. The telescope's frequency range is extremely restricted compared to that of natural starlight, and it is intended to detect artificial lights in space within that range. The planet and star have an intriguing interaction. Solar panels may collect a lot of energy while facing the star, and scientists are also interested in the light that bounces off these panels. Like Earth, Proxima Centauri b experiences day and night cycles while circling its star. The nights are significantly colder, and the days are scorching. However, this isn't the worst aspect. It may not have an atmosphere, which explains why the temperature fluctuations are so drastic. After a sweltering day, the temperature drops significantly because there is nothing to trap heat throughout the night. In the absence of an atmosphere, astronomers are interested in these extreme temperature fluctuations because they may provide information about whether or not the planet has an atmosphere. The telescope's cutting-edge infrared imaging makes it ideal for examining the planet's heat and providing important information about its atmosphere. The fact that the telescope's orbit precisely aligns with its own orbit makes it much more remarkable. This implies that it will be able to observe the day-night cycle of the planet up close once every 11 plus 2 Earth days. The next stage would be to investigate its contents to discover if it might support life. If it had an atmosphere, methane, oxygen, and water vapor would be strong indicators that life may be present in that area. It would be highly suggestive that it might have conditions conducive to life if these were discovered. However, it is not a simple undertaking to collect and process light from the planet's atmosphere. Though measuring things like water vapor, carbon dioxide, and methane is its primary function, it is capable of handling it. However, this information is essential to comprehending the planet's environment. Even though the telescope is having trouble locating bonded oxygen, a crucial indication in the hunt for life, it is still hard at work scouring the skies. It does, however, monitor other significant components closely, such as ozone, which provides valuable information on how robust a planet's atmosphere may be. Scientists are becoming more and more excited about learning the mysteries of distant planets as they examine the data from this telescope. We are getting closer to the answer to one of the greatest mysteries of all. Is Earth the only location in the cosmos where life exists? It is limited to observing a small number of reasonably nearby planets at this time. In order to conduct a more thorough examination of these far-off planets, focus is shifting to more sophisticated instruments such as the extremely large telescope, YELT, which is scheduled to start operations by the year 2882. By providing a far more detailed view of these planets, this new telescope will aid scientists in determining whether or not they are potentially home to life. The data it provides is changing our understanding of the cosmos. Despite the fact that the James Webb Space Telescope is performing an amazing job, not only will the knowledge we are gaining today alter our perception of the universe, but it will also influence how space travel develops in the future. The dazzling light from far-off stars is to be blocked out of future space telescopes in the same way that we block the sun with our hands to improve our vision. This will make it easier for scientists to see the faint planet reflections and investigate the atmospheres to determine whether or not they could be home to life. It is difficult to distinguish between gases originating from natural processes like volcanic eruptions and life forms in the atmosphere of a planet. Now that these fascinating results have set the stage, we can focus on how these findings will influence our future exploration of the cosmic unknown. The James Webb Space Telescope's contribution to the search for extraterrestrial life is immense. Scientists are putting a lot of effort into enhancing their techniques for distinguishing between these signals, which will facilitate the search for actual signs of life. But discovering life is not the only goal of this quest. It also aims to discover more about these far-off worlds. We are currently seeing early peaks of what future space explorations may find, thanks to the James Webb Space Telescope. Each new finding expands our understanding of the cosmos and challenges what we already know. We have questioned if we are the only species in the cosmos for as long as we have existed. This telescope is now being used to scan various sky regions for indications of extraterrestrial life. Scientists are putting a lot of effort into proving that life exists elsewhere in the universe, as the theory is growing in acceptance. Jill Tarter and Thomas Pearson, two American astronomers, launched the Search for Extraterrestrial Intelligence, SETI, in 1984. They established a non-profit organization to use the 42 dishes of the Allen Telescope Array, located in the foothills of California, to search for radio signals from space. These signals are an important tool in the hunt for life because they can travel over long distances with little interference. The SEI Pro program has been listening for signals from extraterrestrial civilizations for more than 30 years, but they haven't heard anything distinct. Jill Tarter doesn't give up hope. She thinks that we are closer than ever to making a significant discovery thanks to today's cutting-edge technology. Tarter envisions this endeavor growing into an international undertaking that unites people around the common objective of discovering extraterrestrial life. The scientific community recently became very excited about a new NASA report. It suggested that something as amazing as city lights on a distant planet could have been captured by this telescope situated 1 million miles away from Earth. It allows us to investigate the secrets of the cosmos in a way that has never been possible before, providing hitherto unattainable information. The purpose of this telescope is to detect objects that were previously invisible. It helps scientists understand how galaxies, stars, and planets are formed. Now that it has a high-tech camera and specialized filters, astronomers can examine the colors surrounding far-off celestial bodies in greater detail. These instruments allow them to study various light wavelengths and gain knowledge about the chemical and physical composition of planets and stars. It searches for indications of life in the atmospheres of other planets in addition to just looking. Thanks to the telescope's unparalleled capacity to explore the depths of space and time, significant discoveries have been made. The discovery that the cosmos has far more mass and massive galaxies than previously believed by astronomers is among the most unexpected. They now have to reconsider their theories on the origins and expansion of the cosmos. Our curiosity about extraterrestrial life is piqued by every new finding made with this telescope, which also helps us comprehend the possibility of life elsewhere in the universe. As we continue to push the frontiers of space exploration, it provides us fresh insights into faraway places. The intriguing aspect, though, is that as we understand more, new questions start to arise. About 20 years ago, the space beyond our own solar system was mostly unknown. We had very little knowledge about the planets circling other stars. As of right now, more than 4,000 exoplanets have been discovered by scientists. This illustrates exactly how far we've gone in both our curiosity and technology. NASA, a leader in space exploration, believes this is only the beginning. They estimate that there may be trillions of planets in our galaxy alone, each with its own secrets. The desire to investigate space and learn more about the universe is unwavering. Scientists continue hunting for any indication of life beyond Earth, and sometimes they get incredibly close. A significant event occurred when a Galileo spacecraft circling Jupiter discovered evidence pointing to the possibility of plant life on a distant planet. This was a really important finding. A biosignature, basically a hint that life may exist, was discovered by scientists. Here was the vegetation red edge, a method of identifying plants by their light-reflecting characteristics. In light of this, the telescope is now prepared to go much beyond finding planets in the habitable zone or the precise location orbiting their stars where circumstances can sustain life. Furthermore, the virtual reality engine, VRE, and other new techniques may fundamentally alter the way we look for planets that may have intelligent life forms in addition to basic ones. The intriguing element, though, is that the goal of this next stage of space exploration is to comprehend the vast, uncharted regions of the cosmos. Imagine sunlight penetrating far-off planets' atmospheres and splitting into many light wavelengths. The atoms and molecules in the planet's atmosphere absorb these wavelengths, forming distinctive patterns known as spectral signatures. These are like cosmic fingerprints, and scientists study them to learn more about the likelihood of life on those far-off worlds. Scientists believe that when a planet passes in front of a star, the telescope will record the light flowing through the planet's atmosphere. This suggests that it might aid in our understanding of the composition of atmospheres on far-off worlds. Planets similar in size to Earth commonly contain a mix of carbon dioxide, nitrogen, and oxygen in their atmospheres. While it's possible that life exists on some of these planets, the discovery of odd or unique compounds may indicate the presence of other, more evolved forms of life, or perhaps intelligent civilizations. Chlorofluorocarbons, CFCs, for instance, are man-made chemicals primarily used in cooling systems. These might indicate the presence of intelligent life if the JWST finds them on another planet. Astronomers would have new opportunities as a result of this finding, including the ability to investigate planets' atmospheres and consider the potential of extragalactic life. The next segment will look at how these technological wonders could change our investigations in the future as we continue on our adventure. Life under extreme cosmic conditions brings up limitless possibilities, many of which are extremely different from the life we know. We frequently envision life needing moderate, steady settings, but the truth might be far more variable. Take extremophiles, for instance. These microscopic organisms cast doubt on our conception of the possible habitats for life. They can survive in harsh settings with pH values as low as 3 or at extremely high temperatures exceeding 250 degrees Fahrenheit. Their resilience in the face of extreme adversity demonstrates how adaptable life can be, even in locations that we may consider inhospitable. However, this is only the start. Finding life in these odd locales might revolutionize our understanding of the cosmos. As we continue our quest for planets that may harbor life, we're only now beginning to realize the true extent of human possibility. Since space exploration is a vast area with several avenues, a comprehensive and wide-ranging search for extraterrestrial life is necessary. A fantastic place to start is with planets like Earth that circle stars like our Sun. However, it's also critical to have an open mind and search in less apparent areas. One example is exoplanets,